welcome back to my channel. Today we'll discuss regarding design of steel structures in Ecet pattern. Design of steel structures. Generally I already made one video regarding the marks distribution of this subject, so some 8 to 11 marks will be there, and this subject was introduced from 2017 when the CBT test has been started. CBT means what? Computer based exam has been started. So coming to the number of chapters we have here is, that is introduction to the steel structures, next design of fillet welded joints, joints or connections, next design of tension members, next design of compression members, next design of beams, and last one is design of roof structures. So from these chapters you may expect from around 8 to 11 marks. So these are the marks distribution as I am expecting, and I have referred the old papers. Based upon that one I have given the marks distribution of each subject. And coming to generally what is the, we'll see some of the general anatomy of steel structures. Means you will be designing a beam, okay, next you will be designing a column, next in general roof floors and bracings and foundations, and next one is connections. So these are the general anatomy of steel building. Now if I go for this one beam, what is this one? This is a flexural member, whereas column is a compression member. So in the compression member there may be three different types of loads. That may be axial load may be there, eccentric load may be there, and sometimes movements will be developed. So the movements will be generally, it may be uniaxial and biaxial. Generally for a multi-storied building the corners will be having both biaxial. You will come across the design of this biaxial compression members in your B.TECH further. And coming to the floors, for a floor you will be having a beams and columns, that is a frame, These bracings are nothing but some extra support, what we call this as a extra support. What is the main purpose of providing this extra support is to increase the load carrying capacity of the member. Next, foundation will be having some column bases, okay, and connections. To make this complete steel structure we will be using the connections. Different types of connections are there: bolted, okay, welded, and somewhat riveted. These are the three different types of steel structures. Next we'll see some of the examples of steel structures. In our daily life we'll be seeing examples of steel structures are, generally if I go for a any indoor stadiums, theaters, you will be seeing these roof trusses, okay. Next you will be having, see these girders, okay, railway bridges will be having girders. Next I said you roof trusses you will be having at indoor stadiums like that. And if you see the power transmission towers, and this may be gantry girders, etc., gantry girders, like that. Okay, these are the some of the examples of steel structures. And coming to the generally a steel structure, okay, steel structure, it is a rigid frame structure. What is this? It is a rigid frame structure, and the frame means it is nothing but having some regular geometrical shape. It is having some regular geometrical shape, and generally it is a combination of different members, in general. Those are compression, tension, and flexural members with some connections. All together only a steel structure can be framed. Coming to the purpose, the main purpose of choosing a steel structure is because of its being a less weight and more strength, thereby increasing the ductility. And coming to here, we'll be having two different types of method, that is working stress method and limit state method. This working stress method, as per IS 800 1984, now it is revised IS 800 2007, we call this method as a limit state method. Now we'll see some of the advantages of this one. It is because of high strength, okay, and it occupies less space than that of RCC member, and material can be reusable, and speedy in construction because curing is not required, speedy in the construction. Next, and modifications can be done easily. Modifications can be done easily. And coming to the disadvantages, it is somewhat costly, and if proper care is not taken, maintenance cost will be high. Maintenance cost is high, and it may corrode. Corrosion may occur. Corrosion take place, and it is low resistance to fire. Next, high temperature stresses because of low fire resistance, and when molding, skilled labor is required. This is regarding your advantage and disadvantage of the steel structure. Now we'll see some of the physical properties of steel structures. First one is unit mass or unit weight. Unit mass means it is rho, unit weight it is gamma, so 7850 kg per meter cube. And modulus of elasticity, Young's modulus of elasticity, it is E, denoted by E, which is constant for every steel, that is E equals to 2 into 10 power 5 Newton per mm square. And Poisson's ratio, it is defined as the ratio of what? Lateral strain to longitudinal strain, which is either mu or 1 by m, which is equals to 0.3. And coming to the modulus of rigidity, either it can be denoted by G, N or C. Either G, some textbooks will be written as G, some can be written as N, or some can be written as C, which is equals to 0.769 into 10 power 5 Newton per mm square. And last physical property is coefficient of thermal expansion. Coefficient of thermal expansion, that is alpha equals to 12 into 10 power minus 6 per degree centigrade. This is coefficient of thermal expansion. And coming to the mechanical properties, first one is what? Yield stress. What is this? Yield stress, Fy. And next one is ultimate or tensile strength. Ultimate or, which is also known as tensile strength. This is the maximum. Ultimate means what? Maximum strength it can bear without getting failed. And you are supposed to take maximum percentage of elongation. So for knowing the maximum percentage of elongation of a steel, any steel, you are supposed to run a tensile strength from a universal testing machine UTM with a standard gauge length. Okay, the standard gauge length. What is the standard gauge length formula? L equals to 5.65 root of A naught. Suppose a member is there, a rod is there, whose tensile strength and percentage of elongation should be known. So for that reason, if I know, suppose for example this is 12 mm dia, what will be the area? A naught pi by 4 into 12 square. You will be getting the area. Substitute in this one, you will be getting the length. So this length is nothing but a gauge length where you will be fixing between the jaws of a universal testing machine and apply the load such that you will be getting the Fu, ultimate tensile strength, and at the same time how much percentage of elongation has been gone. So coming to here, you can check the code if at all. Please, I may be wrong sometimes. So because of these are the codal values, it should be a standardized. They are standard values. Please, even though if you are checking my video, once again you rectify from the code book. It's my suggestion. Coming to here, this is a type of steel is here standard structural steel. In that you will be having different grades. Based upon those grades, so E165 means Fe290 it is. Okay, so E250 you will be having different Fe410 like that, but in this you will be having the categories. So categories, it may be some mineral percentage will be changing. Based upon that one they have been categorized. And here UTS is nothing but ultimate tensile strength in Newton per mm square and megapascal. Here for E165 or 290, see Fe290 means this 290 are nothing but its ultimate tensile strength only, whereas E165 means E is nothing but yielding strength. So based upon the what you can say diameter or thickness of that particular member, that is I can write here dr thickness, that is less than 20 mm, 20 to 40 mm, greater than 40 mm like that. So based upon that one, E165 means yield strength is 165. For that, what will be the ultimate tensile strength? 290. So for E250, 410 will be the ultimate like that. So, and these are the minimum percentage elongation of the values. So for further values, you please refer IS 800 2007. Coming to the German terminology, what is a yield? Nothing but it is a point on a stress strain curve when sudden increase in strain occurs without increase in the stress. The point where sudden increase in strain occurs without further increase in the stress is nothing but a yield. So here in this strain only you will be having upper yield point, lower yield point like that. So that is that portion is also called as a strain hardening portion. What is this called as? Strain hardening portion. You will be learning about this stress strain curves in your strength of materials topic. Here just definition point of view it is more than enough. Coming to the yield strength, the maximum strength that can be applied without permanent deformation of the test specimen. So without permanent deformation, how much maximum strength that can be applied, that strength is nothing but called as a yield strength. So permanent deformation means what? If I apply a load and if I remove it, it comes to its original position. That is nothing but what? It is just a deformation, not a permanent. Without permanent deformation means it's bouncing back. If it is unable to bounce back, then the stresses will be residued inside that one, that is called as a residual stresses. That is another condition. Coming to the ultimate strength, this is the maximum stress value obtained at the stress strain curve. Means after this ultimate strength only, after reaching the ultimate strength only, the test specimen is going to fail. So we'll see the remaining part in the next video. Thank you for watching my video. Please subscribe, like, share and comment for more videos. Thank you.